Okay, so I have the following question. Let's just read through the question first. Okay, so the question says, we have been hired by MEV Supercomputing Center to help design a new processor within the framework of high-speed server project. And after choosing the display, cables, case, and other components, you are left with $460 to spend on the following important components. These important components are usually main memory system, right? The memory subsystem of the entire CPU. It has got TLB, main memory HDD. I didn't maybe talk about TLB recently, but TLB is just another cache within the chip that allows us to cache some of the page tables. Okay, so we don't have to go to memory each time we have an access to the page table. Okay, that's just extra cache. Okay, so it has got latency 15 nanoseconds. Main memory has 180 nanoseconds. Hard disk drive 8 milliseconds. Each one of them can be bought from this electronics company called RAT. The minimum amount you can buy the TLB is 250 entries. Minimum amount of memory is 2 gigabytes and hard disk drive is 300 gigabytes. And you also have associated cost for each one of them. Per entry, for example, TLB, per entry you pay $0.1. For each gigabyte you pay $10 for the main memory, and for each gigabyte you pay $0.1 for HDD. As you go, for example, top to bottom, as you may realize or may have realized already, that we're basically going down the hierarchy, memory hierarchy. So that's why the cost is, it's getting cheaper as we move along from top to bottom, because each entry is becoming cheaper and cheaper, as you may see from this table. Okay, so let's move on to the question. The question is saying, for this question, the page size is assumed to be 64 kilobytes. That's my page size. The computer we design needs to run up to 20 applications. That's an important one, simultaneously, without much performance limitation. Okay, that actually indicates something. That means the working set for each one of these applications must be on the DRAM, right? Without the working set, we have to go through this disk and memory. We have to go through this trashing if we have repeated entries to the disk, which will kill the performance. So each application has an overall maximum size of 1 gigabyte and a working size, set size of 250 megabytes. TLB entries do not keep process identifiers, just a detail, and we have to discuss how you would divide the available funds across the various items to optimize the overall 20 application running computer performance. All right, so that's our objective. There's a note. It says working set is defined to be the set of active blocks for an application. If this does not fit in the cache, performance will suffer, and this phenomenon is referred as trashing. Okay, that's just a side note for your information. All right, so first of all, as you can see, hard disk drive, which is the lowest memory in the memory hierarchy, the lowest level of storage, we need to get some hard drive, okay? And we need to pay the least amount of money, because without the hard disk drive, we will not be able, because it's persistent storage. Without an hard disk drive, we won't be able to store anything, okay? When the power is off. So that's why we have an HDD. We have to have an HDD, and the minimum amount of HDD is 300 gigabytes, okay? So how much we pay for this? We have to pay $30, okay? Because each gigabyte is 0.1. So if you multiply 0.1 with 300, you get $30, okay? So that is going to be off of your budget, which will leave you, 430 minus 460 minus 30 for $30, okay? So that's your remaining budget, all right? Okay, so that's first thing. The other thing is that we would like to have, of course, working set of a given process or given application, which is 250 megabytes, right? We would like to have this entire working set to be in the TLB, right? because in that case we would not need to go to memory again and again. Okay, so that will actually add up in the performance. So if you just look at 250 megabytes divided by 64 kilobytes, which is our page size, right? It's going to give you 4096. Okay, that much entry is needed. Okay, that much entry is needed. So which would cause us, because each entry is $0.1, and if I make sure that my entire working set is in the TLB, then I need to pay 4,069 multiplied by 0.1, $409.6, right? And I have $30, right? So which I can pay. Okay, I can make sure that I'll be able to meet my budget requirements. However, the problem is that you also need some memory, DRAM, right? What do you need as a DRAM? Well, I have 20 applications, right? And each one of them, as you can guess, that their working set, in order to avoid the trashing situation, you have to get all these applications and their working sets in the memory. So which would basically give you 20 multiplied by 256, okay, which is going to be 5 gigabytes, okay, and that means you have to have $50, okay. So what does that mean? Well, that means you don't have that much money, by the way, right? You got only $430. And if you want all of your working set to be in the memory, then you have to pay $50, okay? And the remaining them maybe can be bought some entries from the TLB, or you can buy all of these entries, and the remaining money can be spent to buy some main memory. However, the question is, which one is more time consuming? Is it the trashing or the cache misses? Well, the cache misses are much more, they're also time consuming, but based on comparison between these levels of hierarchy and the time spent in each of them, in the case of a miss, we would definitely prefer cache misses, okay, rather than the trashing, because of the huge gap between hard disk speeds and main memory speeds. So therefore, we would definitely pay $50 and buy all. Buy a memory system, a main memory system or DRAM, such that we make sure that these 20 applications have their own working sets on the DRAM. Okay, so which means in this 430 minus 50, it gives us $380. Okay, left in our budget. So how many entries you can buy with this type of money? Well, you can buy 4,096 entries to store 250 megabyte working set, but now you have $380 instead. But that will cost 3,800 entries. Okay, so you can buy 380 entries as a result, because that's the budget you have. But what's the end result here? What the end result is here is that since the entire working set is not in the TLB, not in the cached in the chip, that means you will have sometimes some cache misses, and you can also calculate the cache miss ratio for this case, which is going to be 1 minus 3,800 over 4,096. Okay, because this is your hit ratio, right? And 1 minus of that is the miss ratio.